Okay, so now we're on question 4. It tells us that compound A is an ester. So we have to name this ester and write an equation of its reaction with sodium or aqueous sodium hydroxide. So I think to help us name this, I'm going to draw a structure. Okay, so one of the things you'll notice is, well, that's how we write the ester in a sort of condensed structural formula Q. Right, so if I'm drawing this above, that carbon in the Q is the carbonyl, and then we have the oxygen. So that's our Q there, and then it goes CH2, CH2, CH3, and our name gets split into 2 parts. So the carbonyl end, all right. So we're going to look at how many carbons are there, and then the other part is the end, or the alkyl group that's attached to the oxygen with only single bonds. And we're looking at how many carbons. So this is propyl. There are 3 carbons. So this is the first part of the name. And then the part with the carbonyl is the part that gives us the anoate part of the name. And here there is only 1 carbon, so it's methanoate. And it's slightly, I can understand it's slightly confusing because in a sense it's the second part of the name first in this structure and the first part of the name second in this structure. But, that's something you can get used to, and it's, you can absolutely handle that. So the name is propyl methanoate. Then we've got to do the reaction, or the equation for the reaction with sodium hydroxide. So even if you don't have to dive right into it and think, all right, I know the answer. You've been given the condensed structural formula for the ester, so just write it. And you've been told it's sodium hydroxide. Okay, you might need to balance, you might not, you don't know yet. So you're then thinking about what's it becoming. Now, in ester reactions, let's just close that up a bit so I've got a bit more space. In ester reactions, you're breaking the bond between the carbonyl, or the carbon of the carbonyl, and the oxygen, which has only single bonds. You're always breaking this bit here, okay? Because, let's use a different colour, that's not very helpful, is it? You are always breaking that bond there. So the orange bit has come from the alcohol that formed the ester, and the blue bit that I've is come from the carboxylic acid. So you remember, carboxylic acid and an alcohol form an ester. So the second part of the name is always coming from the carboxylic acid, so that's why it's the carbonyl part. And the alkyl part of the name has come from the alcohol. Anyway, we are breaking this bond, all right? We're separating the 2 oxygens, essentially, although it's the second oxygen is bonded to the carbon. Now, we're reacting it with sodium hydroxide. So this is a hydrolysis reaction, okay? If we were just using water instead of sodium hydroxide, we would be going back to our original carboxylic acid, which would have been methanoic acid, and we would be going back to our original alcohol, which would be propanol. And when we use sodium hydroxide, we are still going back to our original alcohol. So it's not a word equation, apologies. Propanol. And got to realise that the OH has got to be at the end of the chain. Now, the carboxylic acid that we form is actually going to react with the hydroxide ions. So it's going to be neutralised. So we're actually going to be making the salt So we're actually going to be making the salt of the carboxylic acid. So that's sodium methanoate. So if it helps us or helps you to appreciate, we've obviously made propan-1-ol here. And we have made sodium methanoate. It's a salt. Okay. But you know, this is something to learn to an extent, right? But you have to go over the reactions of this is carboxylic acids and derivatives. It's making esters. That's your alcohol and your carboxylic acid. So you're making an ester and water, or you're doing the reverse. You're doing hydrolysis. It's ester and water going back to a carboxylic acid and alcohol, or it's an ester and sodium hydroxide going back to the alcohol and the carboxylic acid salt. Okay, so a naturally occurring triester, shown below, was heated under reflux with an excess of aqueous sodium hydroxide, and the mixture produced was then distilled. One of the products distilled off and the other was left in the distillation flask. So I think it's helpful to think about this. So you're reacting it with sodium hydroxide. Let's not worry about balancing it. Well, I'll balance it at the end, but let's not worry about it at the moment. Now, if you think about it, you are doing the same thing as the previous question. You have an ester, albeit a triester, and you are heating it, or you are reacting it with sodium hydroxide like you did in the previous question. So the same basic reaction is happening. You've got hydrolysis, you've got a breaking of the ester group, right? So we are breaking each of these three esters in the triester right here. So you always get glycerol. So you have to learn it, right? You have to learn this. In every triester reaction, you get this molecule, every triester reaction. And then the other products that we're going to get are the carboxylic acid salts, right? So I'm not going to draw them, but it's like the above. Salts. All right, so we're making the salts, and those triesters are all the same. So we're going to get 3 of those in our equation, and so we would need 3 there. Now you don't need to know that, but it's just reminding us. Okay. Now, so we have 2 products, right? We have, this product. And we have, you might think, why am I bothering? But we have this product, right? We have 2 products. And it says, draw the structure of the product distilled off. Now, when you look at those carboxylic acid salts, they are coming from this. They are massive. Look at that. They've got 18 carbons, whereas glycerol only has 3. And a big factor in boiling point is size of molecule. I know there are other things like intermolecular forces. Glycerol will have hydrogen bonding, but there is a significant difference in size here. And so the thing that's going to get distilled off is going to be the glycerol rather than the carboxylic acid salts. So the structure, what they're actually asking us here, and I appreciate this is slightly more tricky than maybe some of the triester, triglyceride questions that there might be, because it's not spelt out as clearly as they sometimes are. But it's your glycerol, so you have to, you should remember that every reaction involving a triester that you do has glycerol as a product. You might then not feel 100% sure whether that is the thing that's distilled off, but it's always going to be smaller than the other product, a lot smaller. And so it is highly likely to be the product that would be distilled off and the other product left behind. And so we know that is called glycerol. And then it says give the formula of the product, give the formula of the product left behind in the distillation flask and give a use for it. So just go back up. So the key thing here, it's going to be this, and then we're going to have OO. We're going to have the carboxylic salt end, so OONA. But you've got to remember about, you've got to look at the formula there. You've got to see that CH3 and then 16 CH2s. You've got to remember that. So when we do the formula, it was CH3, CH2, and then there were 16 of them. And then we had our carboxylic acid salt end. And don't forget the Na. And then there were three, if you think about when we did the reaction, or when we covered this, the first and the one we're rolling the sodium, the one that the sodium salts is soap. And I know some of you put biodiesel. That is only going to happen if you've reacted your triester or your triglyceride with methanol, because then you get methyl esters. But here it's a soap. Oh, incidentally, that should have been 6 marks. So I hope that made sense. That's, again, it's probably an area you just want to go back over. There is a video, one of the carboxylic acids and derivatives videos, of maybe it's the original one, the first one out of the two, because I think the second is acylation, where towards the end I go over the whole the triglyceride bit. There are 3 reactions. They all have the same structure. They're just, the only variation is the second reagent, the reagent with the triglyceride and then the non-glycerol product. But they're not hugely different. You can absolutely get your head around that. But any questions, let me know.